Hi, my name is Curtis. I'm hoping to, I have like a slightly different talk than some of the detail weeds or technical details, but I'm hoping to inspire you to kind of take a simple idea, extending the core, some of the core library features in Elixir, and then create cool things. So unlike my colleague Austin, I do not have candy to throw at you, but I'm also not a doctor. So I have this is part of my family, just a little bit about me. I live in San Antonio and I work at TSS. So how many of you use these technologies on a daily basis? Okay, cool. I know. So part of my talk is like taking a thing, turning it into a real boy. Bit of context. Okay. Nope, too fast. We had this module at work that's called Task Runner. It was just doing, well, what it takes an anonymous function and then running a task behind the scenes, and then the code would not care what it would return, and then you're kind of like, cool, moving on. But I had a couple questions. There's no observability. What's the error handling? Is there any rate limiting? Are we just spinning off a ton of these? And what's sort of like the linking strategy behind the scenes? So I wanted a dashboard. I wanted to see, I'm a visual person. We had this like automation thing that we were building out for our sort of dispatchers, where they could just toggle on the thing and dispatch drivers, and I wanted to see the messages that were kind of happening behind the scenes, and that was kind of the inspiration. So I built a little quick dashboard to see all the messages that were happening, so I could see in real time what was happening within the system, so I could get some insight. So let's talk a little bit about how that works. So who here has not heard of the beam? Yeah, okay. I don't think you can hit a book without hearing any of these things. The first paragraph is going to talk about either concurrency or fault tolerancy or scalability or isolation. And how this all works is processes. So processes are lightweight. They have isolated memory. They each get their own stack and heap. There's probably a whole talk you could give about garbage collection. But the primary thing is that their spin up time is microseconds. They take no time to spin up. And the beam handles this all via the scheduler, which scales based on how many processes you have. This is right out of the Elixir in Action book. It doesn't have the load balancing in here, which is kind of important, because as you scale and as a scheduler isn't doing anything, it will do task stealing. So it'd be kind of nice to have a little graph here about that, but in a very high level, this is how this works. And so when you get to fault tolerancy, sorry, I didn't realize the animation would be so slow. You get this thing called let it crash. Right, and Joe Armstrong hammered this in with the way processes work within the beam, which if you're ever scanning the Erlang forums with the email threads the email threads going on behind the scenes that you can read, they're still up today. My favorite quote from him is, you can never make a fault-tolerant system using just one processor, because if that processor crashes, you were stumbling. So, what is a process? It is, as Pierre elegantly articulates this, he's a member of the EFF, or EEF, EEF. I think so is, yeah. They're just a sequence of functions, function calls interspersed with basically receives, which are just callbacks, to pick something out of a mailbox. That's process. There you go. You can find this, I think it's probably too small, but if you want to read the email thread there, he's going on to talk about how processes in Elixir aren't actors. So there's like a really good information dump on why processes are differentiated within the beam from actors. So that's a fun little dive if you want to go down that rabbit hole. All right, so let's talk about tasks. How many of you have actually manually spun up a process? Very cool. More than I expected. Basically, you spawn a process, and then you can monitor it, and that's the receive block that I was talking about for linking. And Learn You and Erlang has a really good sort of image on this, where you spin up the B process, and when it terminates, it will send an exit, and then the reason you can capture that however you want. That's good, but it could be better, right? How clean is that? Elixir code is really nice and elegant and clean to read. So good. All right, streams. My talk kind of a little intersection with the previous two. That's not intentional, that's just how it worked out. You may have some code that is a task that spins off a stream. Never do this. This is just for an example purposes. But if you make a bunch of API calls to external systems, then you don't want to maybe not handle them all concurrently simultaneously to either crash external their system. And this example is just maxing the concurrency to 10, so that if you have 1,000 API calls, your system isn't making all of them all at once. So the way I think of streams are, this is my dog Bailey. Streams are lazy, right? When you take an enum, when you're using the enum API, things are eager. It will take, in this example, it will take 1 to 1,000,000, process everything under the enum map function. Then it will filter all 1,000,000 based on the condition there, and then it will take the first 5. So when you do this with a stream, for those if you haven't messed around with streams, it will basically do this. It will load the data into memory until it meets the 5th condition here, and so you're not actually going through the entire chain all the way to 1,000,000. Who here actually, if you know math off the top of your dome, anybody want to take a guess on how many iterations happen here? If your condition is trying to find the remainder of 3? Again, no candy. Okay. It's just 15. So in this chain here, it's just multiplying by 2, goes through until it finds the 5th result that beats the condition, and then it's done. What I did was I just took this, I wrapped it with the Erlang module timer, and then just timed it. You can see, I think that's microseconds, but it is absurdly faster. So yes, anyway, so debugging. We have a couple debugging tools that are available to us: DBG, Inspect, IXPry. How many of you have actually used IXPry? Yeah, okay. It's not something I've played with too much. I typically reach for DBG or IO Inspect. Here's a couple examples how that works. If you're deep in the weeds of Elixir, this is probably rudimentary to you. If not, the way this works, because I have a couple examples. When you're using DBG, it will show you the whole transformation chain. So as you're transforming the data, you can then see it. I use this all the time when I'm trying to figure out how the transformation chain for the data, in real time. I often also use IO Inspect. It's more of the scalpel approach. I prefer this as well. Okay, so taking a step back, this is how tasks and streams kind of work within the beam. When the task runner was spinning up these tasks, I wanted a way to monitor this in real time. So there are a couple ways you could do this. You could use live dashboard, you could use telemetry, you could use observer. If you're in production, it's probably best to stick with the telemetry so that you can get more data out of your instrumentation. I did actually have a use case where I needed to use Observer on a server. So if you need to use Observer CLI, this is really cool. So if you need to shell into a remote system to see what's happening in real time on the machine, I really like this library. It uses recon behind the scenes. So anyway, if you haven't heard of Observer CLI, very cool library. You should play with that. All right, so I had a coworker who had asked, well, why not just use Oban or Broadway to sort of like handle this so you can just use one of those existing dashboards? And I was like, you know what, that's pretty good. I should probably add this to the talk. So I had Claude sort of create a decision matrix where it was like, you need an immediate response, because I didn't know all the answers of why you wouldn't just use Oban. Oban also doesn't, or Oban and Broadway don't use anonymous functions. You can't just take an anonymous function and chuck it in and get an answer. They're more for like scheduling jobs, or if you're doing a deployment, then it can kickstart off those things. So if you're not familiar with Oban or Broadway and you're running background processing, I think I saw somebody in here with an Oban Pro shirt. I don't know. Baller, whoever that was. All right, so where am I going with this? I still want a dashboard. So why not just take parts of the core library and extend it a little bit? So if you go look at the task struct within the Elixir source code, it's just 4 things. It's the module functionality as the first atom, the owner, the PID, the ref. That's it. This is what it is. So why not extend it a little bit? Why not base encode the ref to create like a unique identifier so that you can subscribe to it and then get real-time updates on your UIs? You could also, I added a status type and some other metadata like the message if you want, the results, started, finished, and an expiration, because you don't want it sort of hanging around on your dashboard forever, so you can set an expiration if you want. All right, same thing with the stream. This is the entire stream struct. There's not much here. You can take a similar method, extend it, and you get something that looks very similar. You get the stream completed, stream total, stream results. The rest of it's pretty much the same. Okay, so take these 2 things and add basically these 3 tools that we already get within the Beam, and you can really create some interesting things. Okay? This is to quickly cover those who aren't familiar with gen servers. They are sort of a running process that you can then add behavior to, and then so if you want to subscribe to messages that it emits, then a gen server is really good at handling that in an asynchronous fashion, because all it does is get messages and then send messages. But for our purposes, we care about monitoring and registering streams and tasks, subscribing to real-time updates, and then discarding, gracefully handling errors or whatever, which is also kind of the idea behind a supervisor. Now, if you have one supervisor that you're sending all your tasks to, that can be a bottleneck, but if you need to, you can sort of extend your supervisor to create some to have more graceful error handling, but really all I cared about was just the initial, if there's an error that's happening, just send it back. And then Phoenix PubSub, which wasn't really a thing that I used until I came to TSS, but it's really efficient at sending messages to those who are listening. That's all it does. So I present to you Task Overlord. Okay. So with this server running now, this is going to be, I won't bore you with all the code, because this is up on GitHub if you actually want to go do a deep dive. But essentially, all that's happening with the gen server is just registering a task and handling the messages that get sent back, like discarding a task. I should have started with. Here is the overlord task, which is the extension that I showed you earlier. This is the stream. So same code. There is no difference. So with that, I built a thing. Live demo, here we go. Okay. For demonstration purposes, it's just spawning a task and a stream every 10 seconds with an error rate of like 20% or something. So since I've been on the AI flywheel, as Isaac put it earlier, I had it sort of just kind of go ahead and create some interesting dashboard concepts. The first one is the card view, where it will display sort of the progress of the stream happening in real time. I have a thing in my way. And it will sort of display the error if it's failed. So all we did was we took the core library, the core task and stream libraries, extended a little bit, and with some simple gen server and some pub sub, we created some real-time dashboard, which shout out to Chris McCord for, the Elixir live view. And then since I'm a terminal sort of power user, I had Claude go create a terminal dashboard. So in real time, this will show you sort of a live feed of what's happening. This is kind of like, to me, this is pretty rad. You can sort of see some like random like report generation, email sending. The system metrics, I think, are not, they're stubbed in, they're not real. But what is cool is you can see sort of your success rate here as part of the analytics. And since I kind of am a power user, I kind of wanted to run some commands. So what are some of those? I created a little modal here where I can then look at some quick actions here, and I can get some help, some status. The way that works is you just enter a command. Oh, very cool. The escape doesn't work. There are bugs, but this is for demo purposes. So you can get status. You can prune, get some tab completion here for any commands that you might think of. So anyway, yeah, that's pretty much it. You can do some really cool stuff with simple ideas within the Elixir ecosystem. So that's all I had.